vocabulary words we're looking for: waves, wavelength, amplitude, medium, transverse waves. You guys can read. I'm not going to spend a lot of time on that, but you are going to recognize those. So also, a lot of my slides you guys have already talked about yesterday, so it shouldn't be like crazy news to y'all. So what is a wave? Go ahead. Yeah, so it's just a disturbance that transfers energy from place to place. Energy is the ability to work, and it's important to remember that the energy carried by a wave. Energy is carried by the wave, like here, where it's lifting up the ship. So yesterday, y'all talked about two kind of waves. You talked about a mechanical wave. You talked about electromagnet waves. Electromagnet, I'm not really going to get too much in, so we're just going to focus on the mechanical waves and the mediums that they travel through. So a mechanical wave travels through a medium. What's a medium?
The middle point.
A medium is just anything, a substance or material, solids, liquids, gases that carry or transmit energy. So the ocean would be what kind of medium?
Solid. Liquid.
It's water, so a liquid. What about sound waves? Gas, right. So yesterday when you guys were up here and y'all had the rope, y'all remember that? Y'all were making the waves with the rope. What would the rope be? What kind of medium was the rope? Solid, that's right. What causes a wave?
Sound waves.
Okay. Waves are generated when a source of energy forces the matter in a medium. So remember, the energy goes through the medium, which is the solids, liquids, or gases, causes them to vibrate. So we all kind of know what vibrate means, but I wanted to put on there that they can go back and forth or up and down. What is the source of energy in my picture? A man.
No.
Whoa, what?
A stingray, right. Are these stingrays or are they manta rays? Do y'all know?
Yeah, that's what I was trying to say.
Yeah.
Man.
Alright, so wave classifications. So we classify waves by how they travel through the medium being the gas, the solid, water, whatever. So transverse waves are waves that travel at the medium at a right angle, and if y'all need a mathematical reminder, here it is, right, 90 degrees. Example of transverse waves, the electromagnet waves we're not talking about. The waves of a guitar, so when you strum the guitar, that's a wave. Water ripples, what about earthquakes?
Yeah.
What kind of waves do earthquakes have? It's on the board. Seismic waves. Yeah. So, and y'all talked about this yesterday. The direction of the wave goes this way. The direction of the medium is this way. And here's my doodle for the day. Parts of the transverse wave. So, do y'all remember this hot pink line right here? What would that represent? Do y'all remember from yesterday?
Rest point.
Yeah, resting position, midpoint. Yeah. The blue line, that's going to represent my wave. So, if we were to measure, and y'all need to pay attention because the whole lesson's on this right here. If I were to measure from the resting point to the top of my wave, that's considered the amplitude. It's measured in joules. So this is the energy of the wave. And then the wavelength that's measured in nanometers, that's going to be the distance between the two top points of the wave. What is the top point of a wave called? The highest point of the wave is called a crest. That's right. Does anybody duck hunt? You do? Anybody just like birds and are knowledgeable about birds? Okay. Does anybody know what kind of bird this is?
A duck.
It is a duck. What kind of duck?
A duck with a big head.
He does have a big head. It's called a hooded merganser because it's got this big hood on it. But I want to use this picture because no, these face, that's not just his head, those are feathers. So on any bird that has all the feathers on top of his head, that little tuft of feathers are called a crest. So I just wanted y'all to remember that, like a visual, color-coded, top of a crest, top of a wave is a crest, top of the bird's head is a crest. What about people that have animals, like horses and donkeys and goats? What do they drink water out of? A trough. See how the trough has kind of the U shape? The trough that an animal drinks out of has a U shape, a lot like the bottom of this wave, right? So we're going to remember that waves carry energy. The energy that the waves carry, we call that amplitude. So if a surfer goes out here in the ocean and he's looking for the best wave, this big wave right here, we could say that tall wave carries a lot of energy, so it has a big amplitude. What about her hands in the water creating these little bitty ripples? How much energy is right here? She has little energy. A little bit of energy creates a little bitty wave. So if a big wave has a big energy and a big amplitude, what do we say about this one? Yeah, because energy is amplitude when we're talking about waves. So a little bit of energy, lower amplitude. That's right. Big wave,
Bigger amplitude.
that's right. So smart. Who has other examples of high amplitude waves? Yeah.
Like when fish ripples.
Fish ripple, right. So, okay, so if a 10-pound bass jumps up out of the water, slams, creates a big ripple, what kind of energy did that fish put in that water? It's a big wave. That's right. So if just a little tiny little sunfish or a little minnow just
Low.
right, because it's a little what?
Little mass.
Little wave.
Little way.
Right. Who has another example? Yes.
Sound vibrations.
Okay. What about who's been late for school? Piper, raise your hand. I'm late for school a lot, I'm sorry. When we drive out front, there's two people out by the flagpole. What are they doing? Putting the flag up, right? So Arkansas this time of year, what's usually going on outside? Wind, rain, possibility of tornadoes. Okay, so let's say we go outside, the wind is going crazy, right? What is that flag doing? Going fly. What kind of energy is that flag? What is it showing? Well, we're talking about energy, we're talking about amplitude, so. Go ahead. Yes, go ahead. It's got a high amplitude because that flag is just beaten to death up there. Well, what if it's just a calm summer day and the wind is just a little bit of a breeze? What's the flag doing?
It might stay still.
It might stay still, but if it were to move just a little bit, what could we say about its energy? Yeah. 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 So what about, how many people, have y'all gone out to the pond and like skipped rocks or thrown little rocks in? Oh yeah. Yeah. So if I take a little pebble and I throw it in the water, what kind of wave does it make?
Low amplitude.
A low amplitude, because that little bitty pebble just makes a little bitty wave, right? Well, if I lug a big boulder from the parking lot out to the pond, let's just say I have mussels, and I toss it in, what kind of wave does it create?
A big wave.
Yeah, it has a lot of amplitude, doesn't it? We talked about seismic waves, right? We talked about earthquake waves. All right.
There are more tsunamis in the Pacific Ocean than any other. So in 2004, the world was taken by surprise when one of the largest recorded tsunamis of all time took place in the Indian Ocean. On December 26, 2004, Indonesia was rocked by the second largest 25,000 men, women, and children lost their lives.
The Indonesian earthquake had as much energy in it as the total energy consumption in the United States in 1 year.
This enormous burst of energy had been released in just seconds. Once again, the world had been reminded of the Earth's awesome power. In the last 50 years, scientists were finally able to confirm a solid link between earthquakes and tsunamis. Although the Earth may seem to be a solid sphere, beneath the oceans and continents it is divided into 8 major and many minor segments known as tectonic plates. Where they meet, they can grind and jostle against each other at fault lines, causing earthquakes. Geologists had long thought that the Cascadia fault line was incapable of generating a major quake, but Atwater's investigation has proved that it was highly active. The big worry for Atwater and the thousands of people who live in this region is that the Cascadia fault line bears an uncanny resemblance to another highly active fault line, the Sunda megathrust. It was an earthquake along this fault that was responsible for the Indian Ocean tsunami that killed nearly 250,000 people.
When we get two tectonic plates coming together, such as the case of the Indonesian tsunami in 2004, one plate pushes beneath the other plate and it creates lots and lots of friction and tension and drags the other plate down with it. And that process can take hundreds of years, even thousands of years. It's a very slow process. But eventually, the pressure dysfunction of push back up again wins, and it flips like that. And that creates a megathrust, a sudden movement of the seabed, and that's what creates a phenomenal tsunami.
Did y'all hear what he said at the beginning, the other guy? That earthquake was a 9.2. Did you hear what he said about the energy?
Yeah. It was gigantic. It was like
It was more than the US uses like a year.
Yeah, more energy gets used.
Yeah, so that earthquake was a 9.2, produced more energy than the United States uses in a year. So what could we, with that information, what could we say about this earthquake? What kind of earthquake was that? What was the energy of that? A mega earthquake, but what else would we say?
A high amplitude.
A high amplitude. So if a 9.2 earthquake that generates enough energy that the US could, more than the US could use in a year, what would be a little one? What would be a little amplitude or a low amplitude earthquake? Yeah. A 1.5. What would, if this one's killed 250,000 people and it shook up and just destroyed everything, what would a 1.2 earthquake do?
It wouldn't do as much damage.
Okay, anybody else?
It just makes like pop up.
Okay, so with a 1.2 or a 2, there's a possibility you sleep right through it. You wouldn't even feel it. Here's those tech problems that you tell me about. Okay, so we've talked about sound, we've talked about water, we've talked about all these mediums and the waves that the energy go through. But what about a seismic wave that travels through the earth when there's an earthquake? What's the medium there? What medium does a seismic wave go through? The earth. What's the earth made out of? It would be a solid, right? Rocks. When the rocks break and shift suddenly underground, they release energy. The energy moves to the ground, and these seismic waves shake the ground. Do you guys recognize the state?
Oh yeah.
What is it? Arkansas, that's right. What about this? Do these initials sound familiar? NMSZ?
That was one of
the New Madrid, fault line runs through Missouri, Illinois, Kentucky, Tennessee, and Arkansas. Right up here, right outside Memphis, Tennessee is Jonesboro, and this little bitty area. Y'all see that little black cluster of dots in there? Okay, so on the date, and I don't remember the date, but I pulled this from the geology.ar.gov website. Whatever date I pulled, whatever time frame, that's a cluster of little less than 2 point on the Richter scale earthquakes that have hit in that area. And the little red pyramids all over the map, those are little zones where they have gone in and put like the heliocorder of the seismogram, which measure the waves, like the earth. If there's little earthquakes or disturbances or whatever, that measures it. So if we look at this one on this day, this was taken from up like by Mountain View. This red, the red, can y'all see the red waves? So this is a 2.9 earthquake that hit right here. So 2.9, in the reality of things, like compared to the earthquake we watched, that's not a big earthquake, right? 2.9 compared to the 9.2 in the video. But if we compare it to this one with the black lines, what could we say about the energy of this earthquake? It has more, so it has a higher what? Right. What about you guys in the back? What about this?
Oh yeah.
What's the amplitude of this? The red. What's the amplitude of that earthquake?
Tall. High.
Big. Yeah,
Big
big.
what? Big what?
Wave.
Big wave, which means it has big what?
Amplitude.
Has big amplitude, right. What about the little, the blue black lines, guys, up back? What kind of amplitude does that one have?
Those are smaller.
So, if it has smaller waves, then what's the amplitude?
Smaller amplitude.
Yeah. So a big earthquake has larger amplitude, which means what? Has more energy, that's right. So the taller the waves on the graph, that just means that the earthquake is stronger and it carries more energy. All right, I need 2 volunteers.
I'll do. I'll do it.
I'm right here.
No one's picking.
Well, lucky for y'all, I have popsicle sticks with everybody's name on them, and I'm gonna randomly pick 2 people. So,
Dude.
Brady,
Ah!
Carly,
I wanted to do.
What's the flip?
Brady,
Fun fact I wanted to do.
Carly, come on up. The price is right.
Go, Kylie, go.
Yo, Bridge.
Purple or blue?
Why'd you put it in between?
Okay, get over here to this board. Carly, I want you on that board right there. Sorry. Carly, I want you to draw me a high amplitude wave. Pause. I want you to draw me a low amplitude wave. Before you get started, I need to see a straight line representing your resting position.
That's not straight.
Hey, that'll work. That's good. You can work with that.
Already messed up, right?
There we go.
That looks good. All right, Carly, you've got the high amplitude, so show me a high amplitude wave. Brady, show me a low amplitude wave. Step aside, let the class see. Does Carly have a high amplitude wave? Can y'all tell?
No.
No, because like there's so much blue around.
She does. She actually does. That is. What about Brady? Does Brady have a low amplitude wave?
Yeah.
Okay. How do we know?
Because it's
Closer to the rest position.
There it is. Who said it? Closer to the rest position. That's right. So now, guys, I want you to take your markers from the rest position to the top of the crest of the wave. I want you to show me how you measure amplitude.
She got to measure it.
The top of the wave is called the crest, and we measure from the resting position to the crest.
good job.
What is, yes, what is that?
That's the.
That's how we measure what? line showing the class how we measure wavelength.
Oh, I know.
Somebody help Carly. How do we measure wavelength? So, but where out on the wave?
33. From the rest position to the crest.
No,
In the middle.
close.
25.
In the middle.
From the crest to the crest. That's how we measure the wave. Does Brady have his wavelength measured right? Can y'all see his line? Does Carly have her wavelength measured right? From crest to crest. Crest. All right, perfect. All right, thank you for helping me. Good job. All right, y'all can have a seat.
5'8". It's the mark.
Okay, so I've got a couple videos for y'all to watch. Can we all agree that we like music?
Yeah.
We may not particularly like this music, but we all like music. So on this video,
I think
on this video, I want you to listen to how she sings. I want you to listen to her volume. But you can't do it if you're talking. So I'm going to play the video. I want you to tell me what amplitude she has on the second video. We'll watch it, and then we'll compare the two. I just need a snippet. Okay, so that's Erica Badu. I don't know that she's popular much anymore, but what do you think her amplitude was? If you had to say she had low or high amplitude, what would it be? Low. Why would you say it's low amplitude? Anybody else want to add? Why would we say she has low amplitude?
Because she was loud.
Yeah, she wasn't loud. All right, let's see if I can get this next one to come up. Oh, no. What do you think?
Where did it go?
Biking road. Wait, is that little music? Is that little music?
So, what is his amplitude? It's high? Okay. So, guys in the back, what's his amplitude?
High.
Why?
Because
was like,
But compare him, this is the band Slaughter to Prevail, by the way. Compare this band to Erica Badu. Do we still think he's high volume?
Yes.
High amplitude?
Yes.
And we still think Erica Badu
Yes.
is low? Okay, good. Okay, so we've talked about water, we've talked about volume, we've talked about earthquakes. What about lights? What if this summer I want to take my kids camping? I go out to the garage, I get my camping gear, I get my flashlight because I don't want to walk in the dark. I turn it on and the batteries are crusty and the light's barely coming on. Yeah, and so it's got a low light. So what is the amplitude?
Oh.
It is low. Why? Because it's barely lit up because of the crusty batteries, right? So let's say, hypothetically, the crusty batteries didn't ruin my flashlight and I put brand new batteries in and the light brightens up. What would be the amplitude of that? High. Why? Because why is the new batteries in the flashlight? It's a brighter light? Yeah. More energy, a brighter light, that's high amplitude. A dull light, low energy, low amplitude. Okay, now y'all can get on your Chromebooks, get your worksheets, and I'm gonna pull the PHet Lab up on the screen in the front and kind of walk y'all through what I want from y'all. Alright, can I get your attention up here for 5 seconds? Because guaranteed, I'm going to tell you what to do, and y'all are going to have a million questions because you weren't listening. This is what I need you to do. Top left corner, push the button that says oscillate. Top right corner, hit no end. That's going to make the picture window pop up. Bottom right, I need you to have some rulers up. So the only button we're going to be messing with today, bottom left, the amplitude, because we're talking about amplitude today, okay? On your worksheet, in the middle, you've got the little boxes. On the left-hand side, you've got amplitude in 3 boxes. In the top box, under amplitude, before you start playing the game, I want you to write this number. 0.2. In the first box, under amplitude, write 0.2. In the middle box, I want you to write 0.6. 0.6 in the middle box under amplitude. Give me just a second. And in the very last box under amplitude, I want you to write 1.3. Alright, let me see your eyes up here for just a second. The last one is 1.3. So what we're going to do in the amplitude box, you've got a slide bar and an arrow so you can get those numbers I just gave you. You're going to hit play, and your bead on the string is going to make waves. Once it gets going and you got a couple waves up there, hit pause. Take your ruler, the vertical one, that's the one that goes up and down. And how do we measure amplitude again?
Height.
Height. So where do we need to put the ruler? That's right. So the 0 centimeters on your ruler needs to be lined up with that resting position. Now can I measure a wave like that?
No.
No. Because the other part of measuring amplitude is what? From the center line to the what?
The crest.
The crest. So I need to move it over here. 0 centimeters on the resting position, my top bead. Whatever this number is on my ruler, in the box for the amplitude that says whatever number, this is 1.3, I'm going to write in the height box 3 or 4 or whatever that is centimeters. And so you'll work your way down. The 0.2, the 0.6, and the 1.3. Measure all of them, put them in the box under height. Again, the only box with the numbers we should be messing with is this amplitude right here. Also, there's a top part to the worksheet, which is a wave diagram. Fill that out. And then there's 2 questions at the bottom. Fill those out for me too. And I'm just going to circle the room and help if y'all need it.
Wait.
Yes.
You go.
You're on 1.3. So whatever this number is on the ruler, you would put right here for 1.3. So 1, 2, 3, 4, 5, somewhere in there, and it doesn't have to be exact, but you need to be able to see a pattern that low amplitude, low height. So if you come back tomorrow, yes, if you come back tomorrow, you'll be able to tell, oh, that makes sense, high, high, low, low. Headphones. Miss McDonald, can he grab headphones? Does he know where they're at? Okay, I know.
Can I get out?
Oh my god.
Explain.
So now that your wave is being amplitude that you want to, you can pause button. Take this ruler and line up that 0 centimeters with your resting position, which is that black line in the middle.
Oh my god.
Yeah, put that 0 line right there, and you're gonna measure that little wave. Yep. So now, what is that? 0? Yeah. So we're at 0 centimeters of height. And then you'll just go through your other numbers, measure it, and just
Oh my
yeah,
god.
0.20. Yep.
I didn't mean to. So your first number should read just like this, 0.20, not